All right, Bismillah, let's get started. So this is our last part of chapter 16, and here we'll talk about what remains in this chapter are the section on polysaccharides. So please recall that we've talked about monosaccharides, right? Talked about monosaccharides, we've talked about disaccharides, and now what remains are the polysaccharides. Okay. So when we talk about polysaccharides, basically there are three that we'll talk about. We'll talk about starch. We'll talk about cellulose, and lastly we'll talk about glycogen, right? And we'll talk about all of them in one by one. All right. So moving on, the first one we'll talk about is starch. So starch are of course storage form of glucose found in plants normally. And what is important to remember for us is that they are polymers of alpha-linked glucose, and they really are basically, as we'll see, there are two kinds. So you can have 1,4 linkage, and this, if you recall, this was coming from maltose. Remember, if you talk about the disaccharide maltose, so maltose had glucose, alpha 1,4 glucose, right? So you can have 1,4 linkages, and this polymer is linear, and we call it amylose, right? And then you have another set of linkages we call 1,4 and 1,6, and this is called amylopectin, and the polymer is actually branched. So starch is composed of two kinds of polymers. We have amylose, plus it has amylopectin. So again, starch is not just a single polymer, it is composed of two things. It is composed of amylose and amylopectin. The amylose part, the amylose are linear polymers and they have 1,4. Amylopectin are branched polymers and they have 1,4 and 1,6. And all of them are glucose, right? So all of them are glucose linked. So all of them are polymers of glucose. And we'll see how the stuff looks like. So this is amylose. Amylose are, again, this is glucose, glucose, glucose. So all of the glucose subunits are linked with this alpha 1,4 linkages, and this is really essentially, if you have these two together, this was our maltose. So amylose is basically made up of maltose, right? So it's a polymer of maltose. So that's another way of looking at it, and it's a linear chain, and this is what's shown here on here. It's just a linear chain, and you have a bunch of glucose units linked together by alpha 1,4. That's called amylose, right? So again, amylose and maltose are not the same. Maltose is a disaccharide. It's a disaccharide, and amylose is a polysaccharide. Okay? But again, amylose is not starch. Starch has two components, so amylose is just one of the components of starch, right? The other component is amylopectin. So what's shown here is amylose. Amylose has just 1,4, 1,4 glucose, alpha 1,4. This is carbon number 1, this is carbon number 4, and this is down, so this is alpha 1,4. And amylopectin is actually has 1,4 and 1,6. So this is this alpha 1,4 linkage here, right? This carbon number 1, this carbon number 4. So amylopectin has alpha 1,4 plus alpha 1,6. Now how do you get 1,6? Now recall, carbon number 1 is this one here. So if you look at this top one here, this is 6, 5, 4, 3, 2, 1. So if this is down, this will be alpha position. So this is down here. This is alpha 1 going down, and it connects with carbon number 6 on the other guy. 6, 5, 4, 3, 2, 1. So you have this chains. So you have this chains of, I'm highlighting it here, alpha 1,4, 1,4, 1,4 going all the way around, and this again, this is 1,4, 1,4, 1,4, 1,4 going as well all the way around, and then these two chains get connected by this 1,6 linkage, right? So this is the 1,6 linkage. This is the 1,6 linkage here. Okay, so if you think of it, there's two chains going parallel and they're connected by 1,6, and then and so on and so forth. And that's amylopectin, right? So I think there's maybe we'll talk about it a bit later on. I'll draw the structures, you get a bit more. So the second class we'll talk about of polysaccharides are these cellulose. Now cellulose is really straightforward. Cellulose, you can think of, they are polymers of cellobiose. Now if you remember, cellobiose was this guy where you have glucose and another glucose and linked together by beta 1,4 linkage, right? So they have this beta 1,4 linkages. They are of course found in plants. They're glucose units and just homopolymer, just one chain. So cellulose is just one chain. Starch has two chains, right? Amylose and amylopectin. Cellulose has just one chain, which is basically just glucose units linked together by beta 1,4 linkages. And as I said, they are repeating of this repeating disaccharides of cellulose, cellobiose, sorry, cellobiose. Okay. Now, of course, if you recall, we talk about this, that human animals can eat starch. This is okay for us, but cellulose we cannot. So cellulose we cannot, right? And and this we can. So why the two difference? Why can we eat starch but not cellulose? Because animals like enzymes that are necessary to break down the bond. And which one are we talking about? We're talking about we don't have the enzymes to break down beta 1,4 glycosidic bonds, but we can break down the alpha 1,4, right? So the structure of cellulose, this is shown here. This is glucose subunit in glucose and glucose, right? And these bonds are beta 1,4 linkages, beta 1,4 linkages, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. And if you look at this part here, always going up, that's why it's a beta, and it's 1 is it joins 1 and number 4. So another way of, so you can draw it like that, or another way you can draw it is basically, I'll show you. You can draw that. So CH2OH up, down, and up, and down. And if it's beta, I'll put up here, and you can have another one. And let's make 3 units, 3 subunits. Okay. So CH2OH up, down, up, down, and up. CH2OH up, down, and up, and down, and up. Okay, so I'm going to join 1,4. So I'm going to take this guy out here, carbon number 1, and take out carbon number 4 here, carbon number 1 here, and carbon number 4 here. And I'm going to join them. I'll use a different color, maybe. Let's see if this green works. Okay, and I'm going to join this part with O, this part, right? So that's what I'm doing, from up to down. So I'm going to put line here, down here, and I can do the same thing, and so on and so forth. And this is my beta 1,4 linkage. So this is this beta 1,4 linkage. This is the beta 1,4 linkage. So you can show it like that, or you can show it, as shown in the bottom. You can show it up and so on, right? But the point really is to keep in mind, you have to show up. You have to show this part. It has to come from up. It has to come from up. It cannot come from down. If it is from down, it will be alpha. So keep that in mind, please. Okay. Oops. So that's beta 1,4 glycosidic bond. Okay. The last one we'll talk about are glycogens. So glycogen, again, is a major storage form of carbohydrate that's found in animals, right? And glycogen is basically amylopectin, but it's a highly branched chain amylopectin. So glycogen is basically a highly branched amylopectin. So again, if you remember what is amylopectin, amylopectin is, it has both alpha 1,4 plus alpha 1,6 branches, right? So the glycogen is just like that. It has more frequent branching, and it's found in muscles and liver in animals. Okay. So this is what they're showing you. This is amylopectin. This is glycogen. Amylopectin has the straight thing should be 1,4, right? This is 1,4, but these branches here are alpha 1,6. So this branch here is alpha 1,6. Where else is the branch? This branch here is alpha 1,6. This branch is alpha 1,6, right? But besides that, all the bonds here are alpha 1,4, right? Now you can see comparing amylose and amylopectin. So in amylopectin, you have branch here, branch here, branch here, branch here. In this thing, you have 4 branches. If you look at glycogen here, you have branch here, branch here, branch here, branch here, branch here, branch here, branch, 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 right? So you can see that glycogen is highly branched, more branches, has more branches than amylopectin, right? So that is obvious here. And again, they're showing you, so just please make sure you see this alpha 1,4 linkages, alpha 1,4 linkages, alpha 1,4 linkages, right? And then you have this 1,6 linkage that you find both in glycogen and amylopectin, right? So glycogen and amylopectins are 1,4 chains with 1,4, 1,6 branches. So you have a chain that goes on, and then you have branches coming up. Okay, so you can basically just to summarize, if I say start, you should have amylose and you should have amylopectin. Let's make it proper. Okay, amylo, can't write. Amylopectin, right? And the amylose is going to be glucose, 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 right? So all of this is glucose, right? And glucose, and this bond is going to be alpha 1,4, right? All of these bonds are going to be alpha 1,4. Amylopectin is going to be same thing. So you're going to have glucose and glucose, and you're going to have alpha 1,4 linkages, right? But then you're going to have another link with glucose. So this is going to be alpha 1,6, and again this is going to be alpha 1,4, and so on and so forth. Keep that in mind. If we talk about cellulose, so cellulose is just going to be just one chain. You have glucose units linked together. So this is glucose and so on and so forth. And this is going to be beta 1,4 linkages and all of them and so on and so forth. Okay. Now, of course, if I say glycogen is just going to be amylopectin, right? Like amylopectin, but more branched. So when I say more branch, you mean more alpha 1,6 branches. So it's going to look basically something like this. Right, so I think this, I hope this helps, and this brings us to the end of our class. And the very last part, I just want to bring again to remind you about the importance of glycolipids or carbohydrates, and we talked about how on the, if you have lipids on the red blood cell surfaces, you have glucose, galactose, and acetylglucosamine. We didn't talk about this in galactose and fucose, but if we have these 5, we have what's called O antigen. So these 5 are shown here, and they all of them A, B, and A and B and O, they all have these 5 ones, but you have changes. You have this part here. So you have N-acetyl-galactosamine or simply galactose. If anybody's interested, we can talk about what N-acetyl NAC mean, but for us, I'm not going to ask you to memorize that. And this again shows you the importance of carbohydrates for cell recognition here. Okay, and this is the end of the class for us, and we'll see you guys tomorrow. Take care. Assalamu alaikum.